So, first chapter of chemistry is matter in our surrounding, and this is the code of chapter. Okay, MIS, and now we will be starting. So, this is the total seven topics are there in this chapter. This is the chapter checklist. First, we will be learning about matter. Second, states of matter. Can you tell me what are the states of matter? Any
Solid,
idea?
liquid, and gas.
Solid, liquid, and gas. Changes of states of matter, effects of change of temperature, pressure, evaporation, and plasma and bone Einstein condensation. So first topic we will be learning, which is matter. So what is matter? Any idea what is matter? What's the definition of matter? Yes, Shreya.
Sorry, ma'am. Sorry, ma'am.
What is the definition of matter?
Ma'am, definition of matter.
Yes.
Ma'am, 1 second.
Okay.
Yes, ma'am. Sorry, ma'am. So basically, matter is basically that anything that has mass and that occupies space.
Very simple. A mass which occupies space is matter. So here, matter is made up of matter, like solid state is also a matter, and this is made up of particles. Matter is made up of particles, and they have a very strong force of attraction between them. Okay, the
Yes,
force of
ma'am.
attraction between them is very strong. That's why the particle can't move from its own place. They can only vibrate at a fixed position. That's a matter. Matter, which is a made up of particles, and they have a very strong force of attraction. They can't move. They can only vibrate in its fixed position. That's a matter.
Okay.
Okay. Okay. And when we will, so what is the solid state? So solid, it means any solid, right? Like ice cube or anything, any solid thing. So they have a definite shape, distinct boundaries, and have a fixed volume. Like if you're holding a pen, so that pen is also having some shape, some fixed volume, and it's occupying some fixed volume in a space, right? And the particles of your pen or pencil, they have a very strong force of attraction that they cannot move, and they are fixed in their own position, right?
Yes.
Yes. And the next point is tendency to maintain their shape when subjected to outside force. Like if, let's say, you are applying force to your pencil, but that pencil is not changing the shape. Why? Because it's a solid. They have the tendency to maintain their shape. They can't move here and there, right? They if I'm applying any force to any solid, they don't have a tendency to move. Why? Because the property of solid is that they maintain their shape. Okay, so next, solids either do not diffuse or diffuse at a very low rate. What's the meaning of diffuse? Metal exception. We'll get into this. Next point. Solids may break under force, but it is difficult to change their shape, so they are rigid. Rigid means tendency to maintain shape. They can even break, like for example, if the pencil, if I'm applying a lot of force in that pencil, that even that pencil will break, but that pencil will not change their shape. Why? Because they are rigid. They have a tendency to maintain their shape. Solids have higher densities as compared to liquid and gas. Now, what is the meaning of higher densities as compared to liquid or gas? So let me give you one example. Let's say this is a any solid. So solids will have what? Lots of particles in it, and they matlab, like here was the point now that they have a very force of attraction between them, so that the particles can't move and they can only vibrate in their fixed position. So it also looks like a tree. Like if you will see a dense forest, so the dense forest is covered with lots and lots of trees, so that the trees can't move, means they have a very high density. And like Amazon forest, they have a very high density. Lots of trees are present. So likewise, we can say that like here, this is a solid. So solids are having a lots of particles in it, and they can't move here and there. Why? Because they're very strongly connected to each other, and yeah, they can't move. They can only vibrate at their fixed position. But when as compared to liquid or gas, see, liquid is having some spaces in it, right? Some spaces is there in liquid, and gas is having a lot more space as compared to liquid also. Correct? So now you got it why solids are having high density than both these, liquid and gases?
Yes, ma'am.
And if high density is there, then what will happen? Shreya, if high density will be there, then what will happen? Will they have
Ma'am,
a tendency to move?
no, ma'am, they cannot break and they are rigid. So, I mean, they can break, but they'll maintain their shape.
Huh. And they are very strongly connected. Hmm.
Yes, ma'am.
The force is very strong. Okay, so that was the example of solid. They have a high densities as compared to the liquid and gas. Okay, examples: sugar, sand, rock, stones, copper, aluminium are the examples of substance which exist in a solid state. Your sugar is also existing in a solid state. We can easily break sugar, right? Sugar is also a solid. They have some shape and they are occupying some volume in the space. Hmm. And the formula of density is this, which is mass by volume. Mass per unit volume of a substance is called density. Okay, and here two more exceptions is there in the solid case, which is your rubber band, and second one is your clay. Why rubber band is the exception? Because which regain their shape when external force is applied. So let's say pencil. If I'm applying any external force to that pencil, obviously that pencil will break. No, but if we will take the example of this rubber band, so when I'm stretching a rubber band, it will get stretched, but after releasing any external force on that band, what will happen? The band will again regain its shape. So this is one of the exception in the solid state. Okay, your rubber band is solid, but this is the exception, and you understood why it's a right?
Yes, ma'am.
Why?
Ma'am, because solids, they usually don't have a tendency to change their shape, but elastic solids like a rubber band, when we apply force on them, they change their shape, and then after the force is removed, they regain their original shape.
Huh, yes. And same for clay also, the clay which we used to play. You know? Okay. Next. Next we will talk about the liquid. So they do not have a definite shape. Water, milk, honey, nothing. They don't have any shape. You know? They take up the shape of a container in which they are kept. Let's say this is a beaker and I'm pouring a water in this beaker. So the water will take the shape of a beaker, or if I'm pouring milk, so the milk will take the shape of a beaker. They don't have their own shape, but if you are pouring any liquid in any solid, so that particular liquid will take the shape of that solid. Okay. Liquids change shape. So, liquids are not rigid. These are rigid, means they have a tendency to maintain shape, but liquids are not rigid. Why? Because if you are pouring liquid in any solid, so that is taking the shape of that. So they are not rigid. They are not maintaining their own shape. They don't have tendency to maintain their shape. Okay? Solids, liquids, gases can diffuse into liquids. For example, sugar in water, oxygen dissolved in water, alcohol dissolved in water. So these are the examples of a liquid state. Now the fourth point is the attraction force between the particles of liquid is greater than that of gas, but less than that of a solid. The force of attraction between the particles. So this is the force of attraction between the particles of a liquid, which is what? Which is greater than that of a gas, but less than that of a solid. Here, the force of attraction is greater than the gas, but less than the solid, right? Because solids is having a very high force of attraction as compared to the liquid. And if we will compare liquid with a solid and gas, so the gas is having very less force of attraction as compared to liquid, right? Excuse, yes, yeah.
Yes, ma'am.
Okay. Now, the density of liquid is generally less. Here also, you can see the density of liquid is generally less. Why? Because here we have lots of spaces, which so that the particle can slightly move. But here we don't have any space, so the particles can't move, and they can only vibrate in their fixed position. Now, some exceptions, solid ice is lighter than water as it floats on water. So this is a exception. And what are the examples? Water, milk, juice, oil, kerosene, alcohol. You already know what are the examples of the liquid. Now we will switch into gas. What is the gas state? Gas either have a definite shape nor a definite volume. They don't have any shape. and also they don't have any volume. In the surrounding which we are living, there's a lots of different gases, nitrogen, oxygen, but carbon dioxide, but they don't have any volume. We can't see them, and they don't have also any shape, right? Gases have maximum fluidity and least rigidity. Gases have what? They have a maximum fluidity. Fluidity means the water, and they have a least rigidity. Rigidity means the tendency to maintain shape, so they have a very less rigidity to maintain their shape. Gases usually don't maintain their shape. Okay, and gases are highly compressible, like the LPG cylinder, which is used in so the LPG cylinder, which is used in our homes for cooking, or the oxygen which is supplied to hospital and cylinders, is a compressed gas, right? All that type of gases are a compressed gas, that we are compressing the gas in a cylinder or any oxygen which is supplied to the hospital, so that the gas should maintain any volume of your particular that cylinder. Okay, so gases are highly compressible, means we can easily compress gas, and we can easily fill a gas in any of the you can say any cylinder, uh, any tank. Okay. Next, the particles move about randomly at high speed. One here, what the particles have move about. The particles move randomly at high speed. Now, Shreya, can you tell me why particles move randomly at a very high speed in this gas state? Why not in solid or
Ma'am,
liquid?
because in solids
Mhm.
and liquids, there is not as much a space between the particles as compared to gaseous state. So that's why the
Yes.
particles can move randomly at high speed in gas, while the movement is slower in liquid, and in solids, there is very limited movement, only vibration.
Okay, very good. Yeah. The particles move about randomly at a high speed because they have lots of spaces between them. And due to this random movement, gases exert pressure on the walls of the container in which they are kept. So, if they are having lots of spaces between them, so the gases are doing what? They are exerting a pressure on the walls of the container in which they are kept. Example, cylinder or any other tank. The density also is minimum, and gas is very much lighter than as compared to solid or liquid. Here, the density of gas is also very minimum because they have lots of free spaces between them. Okay, any doubt here in solid, liquid, or gas?
No, ma'am.
Okay, so now we will go through the notes. States of matter. Matter around us exists in three different states: solids, liquid, and gas. So, what is about the solid state? Solids have, solids have definite shape. They have a fixed volume that we already discussed. Solids have a tendency to maintain their shape. They are very rigid. Solids either do not diffuse or diffuse at a very low rate. They can be break under force, they but very difficult to change their shape because of their rigid property. Generally, solids have higher densities as compared to these two because the solids are having very stronger force of attraction, and they don't have any spaces between them for movement. And the example of density is mass per unit volume, which is m by v. What about liquid state? Liquids do not have definite shape. Liquids flow and change shape, so they are not rigid. We can also say liquid as fluid. Why? Because they don't have any shape. And the gases, especially oxygen and carbon dioxide, is essential for any aquatic animals and plants, and also for us to survive. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. Huh? The aquatic animals, how they are breathing underwater? Because they have a dissolved oxygen in the water. That's why they can breathe. The whale, shark, lots of fishes, they breathe with the help of the water. And in the water, we are means the dissolved oxygen is there in the water. That's why they can easily breathe under the water. And liquids are incompressible. Gases are highly compressible. Okay, the attraction force between this is greater than that of a gas, but less than solid. We have already seen solids are having a very high level of force of attraction. Then after solid, then liquid, and then gas. The force of attraction. I'm writing FOA, force of attraction. Okay, then density of liquid is generally less Why density of liquid is generally less? Because they have less freeze, you can say, or less particles, and they can easily move. Now, we'll switch to next part, matter in our surroundings. Now, what is matter? Matter means anything that occupies spaces and has mass in it is called matter. The same thing we already discussed. Matter is of three types: solid, liquid, and gas. Okay, so first let me discuss this part. These are the notes, Shreya. So the same thing we have already discussed. Okay,
Okay.
about gas, about solid, about liquid. Yes. Next, this is very important. Changes of states of matter. What are the changes of states of matter? Can you tell me what's the fusion point?
So fusion point is also known as melting point. So
Mhm.
basically, the temperature at which a solid starts to convert or changes into liquid state is known as the melting point of the
Okay,
solid.
yes. So fusion or melting state is the conversion from solid to a liquid state. The boiling point is the conversion of liquid from a vapor. The sublimation is a conversion from solid to directly gas. Your liquid is not included, is known as sublimation. Freezing point is from liquid to solid, from back. Now, freezing means when we are keeping water in the ice, so that's the change of state of water from liquid to solid, right, in the freezer.
Yes, ma'am.
Yeah, so that's the freezing point from liquid to solid after keeping it in the fridge. And from gas to liquid is known as condensation. Solid, liquid, gas. From gas to liquid is your condensation. And now we will go through this. What's the fusion? Fusion means the process of conversion of a matter from its solid to its liquid at a specific condition of temperature. That's a fusion point or a melting point. And melting point of ice is 0 degree, and boiling point of water is what?
100 degrees.
100 degrees. Now, boiling point. Process of conversion of a matter from its liquid state to a vapor is known as the boiling point. And boiling point of any liquid state is 100 degrees Celsius. After 100 degree, they starts boiling. है ना? We can be able to see the bubbles starts preparing in the water. At a specific condition of temperature and pressure is known as boiling. What is sublimation? So the process of change of solid directly into liquid without passing through the liquid state. Sublimation means from directly solid to gas. Your liquid is not included in this process. For example, naphthalene, camphor, iodine, ammonium chloride, etc. These are undergo sublimation. Means these can directly change their state from solid to liquid without passing through the from solid to gas without passing through the liquid. What is vaporization? The process of conversion of a matter from its liquid to gas is known as vapor. Liquid to gas is known as vapor. Freezing point is again from liquid to solid is a freezing point. What is condensation? The process of conversion of matter from gas to liquid is known as condensation. Now, any doubt in the states of matter?
Ma'am,
How
one
the
question.
hmm.
Ma'am, what's the difference between vaporization and boiling?
Vaporization and boiling. Okay, so here let me go through this definition. The boiling point is the process of conversion of a matter from liquid to gas. है ना? Liquid से gas में जा रही है, so liquid to gas. Vaporization means the process of conversion of matter from liquid state to gas. The same, but here at the specific condition of temperature and pressure is known as boiling, and here also at a specific condition of temperature and pressure is known as vaporization. But the main difference between the boiling and what's that? Vaporization is, one second. Excuse me. Yeah, actually, I went to drink water. So, boiling point. First, let me talk about vaporization. See, Shreya, vaporization is the phase which is changing of a liquid or of a solid into a vapor is known as vaporization. What about boiling? Boiling means the phase change of a liquid into a vapor is known as boiling point. Vaporization means solid or liquid. If any phases changes into a gaseous state, that's known as vaporization. And for boiling, if the liquid is changing into a vapor, is known as boiling point. Boiling is what? Boiling is the unnatural process, okay, where the liquid gets heated. When we will heat a liquid, then what will happen? It will attain a boiling point. But for the vaporization is due to the continuous heating of the liquid. तब उसको बोलते हैं vaporization. But boiling is a unnatural process where simply your liquid is converted into um, that when liquid gets heat up, so it will convert it into a boiling point. But vaporization is a continuous process of heating of the liquid. And here the liquid or solid is converted into vapor, and here the liquid is converted into vapor is known as the boiling point. Now here in the boiling point, why liquid is converting into vapor, and why I'm saying that when liquid is converted into vapor, that's known as a boiling. Because if we are keeping a water or any milk, let's say any liquid thing, any liquid state, after 100 degrees Celsius, it will attain a boiling state. So the liquid is only attaining a boiling state. But for the vaporization, the liquid, or we can say the solid, is attaining a vaporization. Now you understood
I'm still a bit,
in which.
mom, between the difference of boiling and vaporization.
Okay. So here, see, for the vaporization, can we say that wet clothes drying in the sun is the process of vaporization? Okay, wait, let me write. My screen is visible now.
Yes, ma'am.
Wet clothes drying in the sun. This is, now you tell me that this is the process of vaporization or boiling point or boiling. Vaporization or boiling?
Mom, is it vaporization?
Okay, first question. Second question is drying of a wet hair. Drying of a wet hair. So now this is the process of vaporization or boiling. Okay, so here you told vaporization now in the first part.
Ma'am.
Okay, and what about this question?
Mom, I don't know, mom.
Drying of wet hair is vaporization or boiling?
Mom, is it vaporization?
Yes, it is vaporization. One more question. One more last. Hot tea getting cold. Now, this is example of vaporization or a boiling point. Hot tea getting cold. Sorry, cold.
Mom, I don't know.
Okay. So this is also a process of vaporization. Now I am gonna, make a difference between a vaporization and a boiling point. One second. Okay, so here two more examples we will see. One first is boiling milk, and second question is second example is, okay. Let's take only boiling milk and boiling water. Boiling water. Okay. So now this is a vaporization and this is a boiling point. Okay. Now here in vaporization, the wet clothes also drying in the sun. Means the wet cloth is solid, liquid, or gas. Wet cloth. It means cloth is there. Cloth. We can say it's a solid, now because cloth is having some shape and also having some volume, right?
Yes, ma'am.
And huh. And drying of wet hair. Hair is also having any shape and any volume. So that's also we can consider it as solid, correct?
Yes, ma'am.
So here, just I told कि vaporization means the conversion of liquid or the conversion of solid into vapor. So here, your wet clothes which is drying in the sun is a solid. Your drying of wet hair is also a solid. Means any solid thing or any liquid. So see here, this is a liquid, है ना? Hot tea getting cold. So tea is what? Tea is a liquid. Means any solid or any liquid which is converting into vapor. Now, if you are keeping our wet clothes in the sun, so what will happen? The water is getting vaporized, correct? So that's a solid, and this is your liquid. Now, both the solid or liquid which is converting into a vapor, that's the process of vaporization. But in the boiling point, we are not considering any solid or any gas, only we are considering liquid. Here, just I told that liquid is only converting into a boiling point. Here, you're boiling milk. Milk is what? Milk is liquid. Water is what? Water is a liquid. So here we are only considering the liquid is converting or liquid is attaining at 100 degrees Celsius. That's a boiling state. But for the vaporization state, we can consider solid also or liquid also. Just like here, the wet clothes which is drying in the sun, and the water is getting vaporized or evaporated. So that's your solid part. Drying of wet hair is also your solid part. Your hot tea, which is getting cold with the help of this vaporization process only, that's a liquid part. So in the vaporization, you're both solid or liquid. Yes,
Ma'am?
Shreya, you went
Yes,
off.
ma'am. Ma'am, sorry, the internet it got disconnected.
Okay, it's okay. So now you got the difference. So, or should I explain it again?
No, ma'am, I understood.
Now, can you explain me?
Ma'am, so basically
With the help of
solid.
this example.
Sorry, ma'am.
With the help of these example only. This one,
Yes,
this
ma'am.
one.
Ma'am, so basically, for example, if we dry the wet clothes in the sun, the clothes are solid and the liquid in the wet clothes is getting dried. So basically, solid or liquid is getting converted into vapor. So that's why it's vaporization. But for boiling milk or boiling water, we are like increasing the temperature for the milk or water to get it to the boiling temperature. So that's why it's boiling.
Huh. Yes. So vaporization is solid or liquid, and here only liquid. Okay. Now, what is the effect of change of temperature? This is also one of the very um, good diagram, like solid here, liquid here, gas here. Now, when solid is converting into, now you have to, learn this. When solid is converting into liquid, that's a fusion. And when liquid is converting in back to solid, that's sublimation. Sorry, that's solidification. Okay. When solid is converting into gas, that is sublimation. And again, from solid to gas is desublimation. Liquid to gas, vaporization, and your gas to liquid is condensation. Okay. So this you have to learn, this diagram. This is very
Okay, ma'am.
important. Now we will see the scales of measuring temperature. Uh, in this scales of measuring temperature, you will have like 2 3 examples on the basis of these three formulas. First formula is the temperature on Kelvin scale is equals to the temperature of Celsius scale plus this. So here we have to find, means if your Celsius is given, then we have to find for the Kelvin. So this is one formula. This is another formula if Kelvin is given and if Celsius is not given. And this is a formula of a Fahrenheit, which is 9 by 5 degrees Celsius plus 32. Okay. So now let me give you one question. So can you solve this question? This one. Convert the temperature of 450 Kelvin into Celsius. So let me show you the formula. This is the formula. Okay, wait, let me write this formula then. This formula, I'm writing it here. Then it will be easy for you. Here for this temperature, degree Celsius plus 50, and one formula for Fahrenheit. But here the Fahrenheit is not asking, but okay, now can you solve this question?
Yes, ma'am.
Solve this example.
Ma'am, one question.
Mhm.
Ma'am, so in school we usually just round it off to 273. So should I use 0.16 in here or should I just round it off and use it?
0.16 is the standard. So if you will use, then you will get exact answer now.
Okay, ma'am. Fair. Ma'am, I got 177.884
Okay,
degrees Celsius.
so let me erase 179.84.
9.
Correct only. Means only you have to simply minus, no, subtract this because
Ma'am, I got 177.
how come 177? Okay, wait, let me check. Convert the temperature of this Kelvin into a Celsius. So you have to apply this formula because you have to convert it into Celsius. So this is given. 473.16 is given, and you have to, sorry, that's another. 450 Kelvin is given, and you have to subtract this from 273.16. So how much is it coming? 450 minus 273.16. It should come 176 something now.
Yes, ma'am.
176.8.
Yes, ma'am. 176.
Okay, but so this is wrong. Yeah, correct. 176.8. Good. So in the next class, we will talk about the latent heat because latent heat is a very big topic, right? And then effect of change of pressure, temperature. We have already seen. This is your the effect of change of temperature. This okay. So in your school, which chapter is going on?
Ma'am, in school, this chapter itself is going on. We completed till here only, effect of change of temperature. We also covered latent heat and we stopped there.
Acha, latent heat covered. Oh, in the next
Yes, ma'am.
class I will cover. Okay.
Okay, ma'am.
Okay. Thank you.